Hi friends! In this video lesson we are going to speak about CCNA Routing and Switching second book, which is called Routing and Switching Basics, and Chapter 1 Introduction to Switched Networks. Video lesson is prepared by Flipped Classroom project under Suleiman Demirel University. In this topic we are going to look for LAN design, switched environment, and we'll take a look for the summary of both of them. Okay, let us start. First of all, let us take a look for the data network. Though this is actually LAN. In this LAN we have a server, we have some computers, and we have a switch. So switch is making switching between these computers. And imagine that this is only network which is forwarding data. Next network type is voice or a telephone network. In this case, in this network, we're going to have the PBX, and this PBX will be connected to just telephones. We saw such kind of network many times in a lot of organizations. And one more network, it's going to be the video or TV network, the same as you're watching the television. And as an example, it can be Alma TV. So you have a cable which is coming to your home, and you see some projection. Actually, here we have a server, and this server is distributing the traffic for you, for your televisions. Now, imagine that you don't want to use these three type of networks separately, but you want to have one single network which will satisfy all requirements that satisfies previous three different types of networks. So we'll take with you data network, voice network, and video network, and we'll converge them. Okay, so we'll just place them into one stream. So, and as a result, we are going to have a convergent network. In convergent network, we usually use such kind of devices like PCs, switch, IP phones, and TVs. Or it can be also a PC with the role of the TV. In this case, you are not going to have a lot of junction of cables which are interconnecting your different networks, but you will have single network, and this network is going to be, as an example, it can be Ethernet. I mean, your network can use Ethernet technology, and it can converge all the networks together. Now let's take a look for the borderless network, or in other case it's called hierarchical network of the LAN, local area network. When you are using hierarchical local area network, you have some layers. These layers are access layer number 1, distribution layer number 2, and core layer number 3. What is the role of access layer switches? As looking for the name access layer switches are giving access for the network for end devices. So all devices which you see below access layers are end devices. End devices are starting communication. For example, let's take a look for communication between PC1 and PC3. So PC1 starts the communication. Communication go by using this way and reaches PC3. So here we have start of communication. Here we have end of the communication. Also, one of the example is the printer. Another example can be voice over IP phone, or additionally we may add here video camera, web video camera, or something else. So the role of access layer switches is to provide access for end devices to local area network. Now it's time to discuss a distribution layer. Distribution layer is distributing the traffic between access layer switches and core layer switches. Distributing layer switches has such kinds of features like they can work with the ACL. It means that they can filter the traffic of the communication. For example, if you want to have such kind of rules that PC2 is not able to communicate with PC1, you can write these rules by using the access control list into the D2 or D1 switch, so that when traffic will come here, D2 switch will make the filtration by using the access control list. And if here we are going to have, for example, PCX, so PCX will be able to communicate with PC1, but PC2 will be blocked. Also, let me tell you that distribution layer switches has such kind of characteristics that they have to be fast. And access layer switches, so they usually not so expensive switches. They have to just provide the connectivity, and it can be such kind of situation that here you have fast Ethernet with the speed of 100 megabits per second, and actually in distribution layer switch we are going to have a faster connection, or it can be 1 gigabit per second. And in core layer switch we may have 1 gigabit per second or even 10 gigabits per second of speed, because access layer switch connects devices directly and devices directly. So if your fast Ethernet speed here is 100 megabits per second directly from switch port to computer, so if you have, let us say, 200 hosts on one switch, then for every switch port the speed will be 100 megabits per second. But when switch 1 will be connected with distribution layer switch, their speed between them has to be faster. Even not 1 gigabit, maybe it's going to be 10 gigabits also, due to that fact that D1 is going to be connected with C1, C1 with D2, and D2 connects to switch 2, which connects another, let us say, 100 hosts. Well, what is the role of the core layer switch? The role of core layer switch is to interconnect distribution layer switches and to be connected to routers. So router by itself is connecting to the internet, and router 2 will be also connected to the internet. So in this example we have with you two core layer switches which are connecting to internet by using, maybe it's going to be different service providers, ISP-A and ISP-B. Also, I forget to tell you about access layer switch features, that they are providing a security control, and you may configure your access layer switch ports that are connecting computers by using security configurations. Like, you may configure switch port security. Like, if you have ports 0, 1, and 2, and if you have here computers A, B, and C, you may say that to port number 0 on switch 4, only MAC address of computer A will be able to connect. If someone else will be able to be connected physically, will be able to connect to your switch, and let us say that it's going to be not computer 1 now, it's not going to be computer A, but it's going to be computer, let us say Y. If you change computer, then MAC address is also changed, and switch 4 can reject different MAC address. So even if physically someone will have access to your switch will block all the traffic. Now, let's take a look for different types of switches. Switch networks form factors. So we have with you 3 different types of switch form factors. And the first type of this switch is the fixed platform switch. It means that number of ports that are available on the switch are limited, are fixed. Like you see in this example, we have approximately 24 ports, and we have here 3 uplinks. 24 ports, for example, with speed of 100 megabits per second, and uplinks can have 1 gigabit per second. So fixed platform switches are not actually limited with the number of ports, because you can just make connection from one switch to another switch by using these uplinks, so that you can somehow extend number of ports. So if you had here 24 ports, so in second switch you have 48 ports. Then you will somehow extend number of ports, but it is this type of switch is still called fixed platform switch. Next type of switch is called a modular platform switch. These switches are having a main board, and on the main board they have some slots. It's like in computer. And this main board is placed inside a box, and if you want to have connection by Ethernet or fast Ethernet or gigabit or 10 gigabit Ethernet, then you have to buy a module, and this module will consist of some ports. You have to take this module and place it to your box, so that your module will be connected to the slots. You can buy one box without any ports. Afterward, according to requirements of your company, you can buy a model, for example, with 48 ports. If your company network will extend in future, then you can buy one more port model with another 48 ports. So, and you can extend your network with the limit only of these slots. The speed between slots is very fast, because they are connected into one main board. And in fact, you have one single switch, but with different models. In case when your models are, let us say, not satisfying your requirements, for example, you bought 100 megabits per second models, but in future maybe you will think that you need to use 10 gigabits per second. Then you can take it off and place new model, but it also depends on the main board performance. And third type of switch form factor is stackable switches. Stackable switches are looking like fixed switches, but from the back side of this switch they have a spatial ports. They have spatial ports and they are connected by backplane cable. This is bigger cable than RJ45 and it's providing high speed connectivity between switches. So Cisco switches can be connected and extended up to 8 switches. So in this example we have only 4, so it means that below of the switches you may also have connection with 4 other switches, and these switches are going to be interconnected with each other by using this way. There are 2 different types of switch forwarding methods in switches. First type of switch forwarding methods is called store and forward. The idea of store and forward method is to check errors via FCS check and perform automatic buffering. But in case when store and forward switching is used, the forwarding progress is slower. What happens when switch forwarding method store and forward is used? Switch receives full frame and make comparison of the CRC value with calculated value of the frame. If values are different, then switch deletes the frame. In this example, computer is sending frame to the switch. Switch calculates the CRC by itself and make comparison with calculation of computer of the same frame. If they are same, then frame is forwarded. If they are not equal to, then switch deletes the frame. Every time when switch will receive the frame, switch will check the CRC value. Cyclic redundancy check. If we have another switch interconnected between these computers, then 3 switches in this example will make a cyclic redundancy check. In comparison with store and forward method, cut-through switching is allowed to switch to start forwarding in about 10 microseconds, and there is no FCS check and no automatic buffering. In this method, switch is just receiving frame header, and it is quite enough for switch to receive only preamble and destination MAC address to start to search the MAC address of the destination device in the table of the MAC addressing table of the switch. In this example, computer will send a header and trailer, and let us say computer is sending a frame. In frame we have header, trailer and a packet. When this frame will come into the switch, switch will first of all unpack this value. Here we have destination MAC address, and in switch there is a spatial table which is called MAC address table. If destination, let us say that this is source, this is destination. If destination's MAC address is let us say DDD, so in switch MAC address table will have information about computer DDD, which is connected to FA00 interface. So that when frame will come into the switch will first of all receive the first part, which is called header, and will take the MAC address of computer DDD, so it's going to be DDD, and it will make comparison with MAC address table. After finding out to which port this MAC address is connected, frame will be redirected to the destination without checking it for the CRC value. Now it's time to take a look for collision and broadcast domains. The word domain by itself defines meaning of area. So we have a broadcast domain, means that broadcast area, and collision domain, collision area. In broadcast domain, we have a network by itself. Broadcast domain is separated by a router interface. In case when you have a router with two connected interfaces to some devices, then you have two networks, network A, network B, and each of this network will be called a broadcast domain. What is the meaning of the broadcast domain? Broadcast, it is such kind of process when one computer is sending information to all computers. Imagine that computer A wants to have communication with computer C. Computer will send a broadcast to find the MAC address of computer C, and this broadcast request to find the MAC address of computer C will go to all directions, including next switch. Next switch will also retransmit this information to all other ports, excluding that port from which switch took that information. This is called the broadcast. And look, let us say that switch 1 also connects to the router. So one request will go to the router, and all this broadcast request will have a border. The border is a router. In case when you will take off this border as a router, and if you will connect this switch to switch 1, then the broadcast will go also to the next switch. And if here we have interconnection with another switch, so all other switches will get the same broadcast request. So network is divided into subnetworks to prevent such kind of situations. Collision domain. As we spoke about the broadcast domain, now it's time to speak about the collision domain. Here we have one broadcast domain, because this is one network. And each port of switch is making a collision domain. So in this situation, we have with you 4 collision domains. Why it is called collision domain? Because if one of these computers, like A, B, C, and D, will send an information to hub, and if at the same time computer D will also send information to hub, in hub there will be a collision. And when this collision will be happened, CSMA CD protocol will start to work. So in this area, in each port of switch, interconnection to each switch port is called collision domain. But in case if you would place, instead of switch at the middle of this topology, a router, then how many broadcast domains and how many collision domains will you have? Let us count them. This is first broadcast domain, this is second broadcast domain, third broadcast domain, and fourth broadcast domain. Here we don't have switch ports, but it doesn't mean that we don't have collision domains. The blue one defines broadcast domain, and red line defines collision domain. So at the same time, on the same topology, we have with you 4 broadcast domains and 4 collision domains. In this video lesson, we describe it with you basics of local area network, including borderless LAN or hierarchical LAN. We describe it with you different types of switches. We describe it with you different types of switch forwarding states like cut through and storing forward, and we define it with you collision domain and the broadcast domain. Thank you very much for watching this video. To see other videos, subscribe to our channel flipped.classroom.sdu